Because insects have exoskeletons, most parts of the body are hard, and the abdomen of insects is really soft. The abdomen is the digestive system of insects and the reproductive center of insects. It is born behind the chest of insects. The abdomen usually has 9 to 11 segments, and the individual species only has 3 to 6 segments. Because it is composed of many links, the connection between each link is membranous, so it can be telescopic. Let's take a closer look at the abdomen of the insect. You see, there is a small point on both sides of each section. This is the insect's spiracles. Spiracles, generally long in 1 to 8 abdominal sections, is the breathing organ of the insect. Although it may seem strange, it is similar to human lung breathing, but it is distributed in different places. For the spiracles of insects, the number and location of the spiracles of different insects may be different, but the locations of the spiracles are generally on both sides of the abdomen of the insects, and they appear in pairs and have the function of opening and closing, which can be used to control the inhalation of oxygen and the exhalation of carbon dioxide. Usually, when the temperature is higher or the concentration of carbon dioxide in the environment is increased, the spiracles of different spiracles can be divided into 2 parts. The opening and closing of insect spiracles is accelerated. Now let's look at the end of the insect's abdomen. The last section of an insect often has a pair of tail whiskers, which act as a sense of touch. Male and female adults have external genitalia at the end of the abdomen. The external genitalia of male insects is called the copulatory organ, which plays the role of mating. Its morphological structure is the key to identify the isolation between species in insect classification. The female's external genitalia, called ovipositors, are used to lay eggs. The ovipositor is usually tubular. Because of the different species of insects, their ovipositor morphology is also different. For example, the egg-laying device of the katydid is curved knife shape, which can help us to identify the katydid well. And the cricket? Its ovipositor is like a spear. In our life, we often see the wasp, also known as the horse bee, will sting people, and this thorn is the wasp abdomen specialized into a slender needle and can inject venom ovipositor. This specialized ovipositor is the result of adaptation to the spawning environment over a long period of evolution. For example, let's take the example of wood wasp to see how the insect relies on the ovipositor to lay its eggs. Wood wasp is a kind of bees that harm the trunk. Female insects can lay their eggs on the smooth parts of the dying wood or bark and the bark holes of the trunk. After hatching, the larvae will drill deep into the xylem and eat, thus causing great harm to the trunk. So how does a tiny wood wasp manage to lay its eggs so easily in a hard tree trunk? By now, I'm sure you can guess it's the ovipositor. The ovipositor of the wood wasp is divided into 2 parts, the ovipositor tube and the ovipositor sheath. The ovipositor tube is a thin black tube, which is wrapped in the ovipositor sheath when not laying eggs. What is most distinctive is that the laying tube of the wood wasp has 2 interlocking valves, each with inverted teeth. When one valve grabs onto the wood to provide resistance, the other valve pushes forward a small step. Then when this valve grabs onto the wood to provide resistance, the first valve pushes forward a small step. In this repeated rapid swing, the 2 valves take turns providing resistance and pushing forward. By this principle, wood wasp spawning tube can drill deep into the wood, and the whole process requires very little force. You see, this is how wood wasps use their ovipositors to lay their eggs deep in the tree trunk. It is worth mentioning that the structure and spawning mechanism of wood wasp spawning tube have inspired scientists to invent a bionic neurosurgical probe that works in the same way as wood wasp spawning tube. The probe, which also has a valve with 2 small teeth, can penetrate deep into the brain but cause only minimal damage. Such a probe could help surgeons significantly reduce incisions in hard-to-reach locations during surgery. After laying eggs, insects often leave some egg marks, which can also help us find the location of their eggs. For example, this is the cicada's egg marks on the branches of trees. The insect ovipositor is amazing, isn't it? But in fact, there are also some insect ovipositors are not specialized, such as butterflies. They only lay eggs by sticking out the end of the abdomen directly, so it can only be produced on the surface of the object. So we often see butterfly eggs on the leaves. The different forms of ovipositors often help us understand the ways and habits of insects to lay eggs. Okay, let's recap today. The abdomen is the digestive and reproductive center of insects. It has breathing passages, the spiracles, and external genitalia for breeding. So let's think about it. If we're going to treat insects with fumigants, how do we get more toxic gas into the insect faster? Use your brain to think, oh, well, today's content is here. Goodbye.